Okay, so we're going to plot those points as they are. So remember, this point right here is actually going to be 2, 3. This one over here will be negative 1, 2. And this one down here will be 1, negative 4. And the instructions say to shift the triangle 3 units to the right and 2 units up. Okay, so that's exactly what we're going to do. Now remember, we've done this problem before at the beginning of the semester. This is where I created a table. So that's exactly what I'm going to do. I'm going to create a table for you. So let's go ahead and do that. And I have it already pre-made with the original points for you. So our original points are, again, negative 1, 2, 2 comma 3, and 1 negative 4 in no certain order. I just picked them like this. Now the first shift that we had was 3 to the right. Okay, so you got to make sure that you kind of remember. Let's go back and remember what we did. Whenever we go to the right, you're going on, or you're moving along which axis? You're moving along the x-axis. Now when you move towards the right, those values keep on getting more positive and bigger. So if we were to create an equation for this transformation, it would be x plus 3. Okay, so that means we're going to take each x value and add 3 to it. So when we do, we have negative 1 plus 3, which happens to be 2. So we're going to have 2 and still keep my y value because we haven't done anything to it. For the second point, we're going to take this x value, which is 2, and add 3 to it, so we get 5. And still keep my 3, my y value, because we haven't done anything to it. And the next one, which is 1, we're going to add 3 to it, and we get 4. And we still keep our y value. Now we move on to the next shift, or the next transformation, and that says that it is 2 up. In other words, we're going or moving along the y-axis. So if we set up an equation, it's y, and going upwards means that your values are getting more positive and bigger, so that would be plus 2 as an equation. So now we take the previous set of points, which are right here, but this time we're not going to do anything to the x values. We're actually going to do the shifting or the adding of 2 units to the y values. Alright, so here we're going to have 2 comma and 4 plus 2. Let's see. I see a mistake here somewhere. Here, right here. This should be 2. I have no idea why I added that. Alright, so negative 1 plus 3 is 2. Okay, looks good to me. Alright, so now let's go back. Let's refocus. So we're going to take this 2y value and add 2 to it, so we get a 4. Then here we're going to keep the 5. And we're going to take this 3y value and add 2 to it, and we get 5. And then for the next one, we're going to keep the 4. And we're going to add the 2 to this negative 4 value, and we get a negative 2. So after you've completed the shifts, those should be our solutions to the transformation. So let's go back to our PowerPoint and see if that is what we got. Okay, so once we've done the shift, it says that your 3 new ordered pairs should be 2, 4, 5, 5, and 4, negative 2, which is exactly what we got just a couple seconds ago. Okay? Okay, moving on. Again, I know you're probably going to get tired of seeing these, but for the next couple of weeks, it's going to be parent functions, parent functions, parent functions. So make sure that you know each of the characteristics as well as the names and the equations that are associated with each of these graphs. So very quickly, again, we have the constant function, linear function, absolute value function, radical function, quadratic function, cubic function, and then of course the other two, which are the reciprocal, or in other words, the rational function, and the greatest integer function, in other words, the step functions. So make sure you do know those characteristics. Okay, now we are going to discuss vertical and horizontal shifts. So the first thing that I want to do is I want to first graph y equals x squared. As you all know, that is our parent function. Our parent function is a quadratic, and the equation for that is y equals x squared. So let's just go ahead and input it into our calculator and draw it. So let's see. I have y equals x squared. And as you can see from the picture, it is indeed a parabola that is opening upwards. Okay, so that's going to be our parent function. All right, let's go back to our problem. Okay, so now we're going to graph y equals x squared plus 2. So what I want you to do is go to your calculator. You're still going to keep that y equals x squared plus 2. Y equals x squared. And then underneath that, I want you to plot y equals x squared plus 2. So that's exactly what we're going to do in this case. So underneath that, I'm going to have y equals x squared plus 2. Okay. Now, as you can see, we're going to explore what is going on. We're going to always compare our new equation with our parent function. In this case, my parent function is the one that is in red, and my new function is the one that is in blue. So if you realize and you look at this picture or this graph, what has happened in relation to my parent function? The parabola has actually shifted, and it has shifted up 2 units. So what I want you to do is I want you to make a note right next to this equation by saying that it has shifted your parent function up 2 units. Okay, now what we're going to do is we're going to graph y equals x squared minus 3. Okay, so let's go back to our calculator, and we are going to, again, still keep our parent function, which is y equals x squared, but this time I'm going to change this equation into the one that I want, which is y equals x squared minus 3. Okay, so let's see what has happened. As you can see, again, my parent function is the one that's in red, and the new quadratic equation is the one that's in blue. That's the new parabola. Okay, in relation to my parent function, which is the one in red, what is the difference between the one that's in red and the one that is in blue? It has actually shifted my parabola how many units and in which direction? It has shifted it 1, 2, 3 units, and it has gone in the downwards direction. So that may be a note that you can add next to this one, and that will be that it has shifted your parent function down 3 units. So for this one, it shifted it down 3 units. For this one, it shifted it up 2 units. Okay, now let's continue with the next one that I want to graph, and that's y equals x minus 1 squared. So let's see what's going on with this one. Alright, so let's go back to my graphing calculator. I am still going to keep my parent function, but this time my second equation has now changed, and it's going to be x minus 1, and we're going to square that. All right, so as you can see, again, the red is my parent function, and the blue is my new shifted or transformed function. Okay, and what exactly has happened? It has shifted your parent function to the right 1 unit. All right, so you may want to keep this in mind. So the note that you want to put here is that it shifts your parent function to the right 1 unit. Okay, and now let's go to the next one. So we've done this one. Now we go on to the x plus 2 squared. Okay, so let's go back to our graphing calculator. And again, I'm still going to keep my parent function, and I'm going to change this to x plus 2. And we're going to see what happened. Again, the red one is our parent function. The blue one is my transformed function. So in relation to my parent function, what has happened? It has shifted it 2 units towards the left. So we make a note that for a function that looks like this, it moves it 2 units. It moves the parent function 2 units to the left. And if you remember, let's make the connection from trig. Remember when we were studying amplitude, horizontal shift, vertical shift, and all that? All of those movements going on. Whenever a certain value was inside with the x, we always thought of doing the opposite. And that's exactly what we apply and do here. If a certain value is inside with the x, then you want to do the opposite from it. Okay, let's move on to the next one that I want you to graph, and that's y equals negative x squared. All right, so let's see what's going on with this one. All right, so I have my y equals x squared as my parent function, and then I have y equals negative x squared. All right, so what really happened? Okay, it actually flipped my parabola about the x-axis. So this negative flips it about the x-axis, and it has now turned into a parabola that is opening downwards. And let's review. A parabola that is opening downwards doesn't have a minimum. It would actually have a what at the vertex? It would have a maximum. That's exactly right. Okay, so again, make note of what happened. And we'll say that it flipped the parent function about the x-axis. Okay, and now let's continue with the last one that I want to do for this type of question or this type of shift is y equals negative x plus 3 squared minus 1. So let's see what's going to happen. All right, so we have negative x plus 3 squared minus 1. All right, so let's see what happened. First of all, if we start here with our parent function, it seems that it shifted it 1, 2, 3 units to the left, and it also shifted it 1 unit down, and then it also reflected it, or in other words, flipped it, turning it into a parabola that is opening down. So let's go ahead and write what happened and make note with the last one. Alright, so this right here, I always like to flip it first. So the minus really tells us that it flipped it about the x-axis. Then this plus 3 is telling me that it actually shifted it to the left 3 units. And this minus 1 is telling me that it shifted it down 1 unit. Okay? Okay, so what I want to do is I kind of want to wrap up what we've discussed and see, kind of make an overall general notation of these shifts. So again, we have h of x equals